Okay, so we've got a circle which has got this equation. And so let me start just by drawing that circle. Here it is. Okay. Now we've got a line that's a tangent to the circle, and the line has a gradient of -3. So it's going to look, I don't know, maybe something like this. Right, tangent to the circle with a gradient of -3. Find two possible equations for L. Well, that's obviously one possible place where L could go. And I suppose if I draw a line parallel to that one, so it has the same gradient, roughly speaking, there it is, almost, then that's my other possibility for L, isn't it? Two tangents of the circle that have a gradient of -3. Okay, so somehow I have to find the equations of these two lines. Now, to find the equations of the lines, I need the gradient of the lines, well, that's -3, and I need a point on the line. Well, that's obviously, those are the 2 points that I need, aren't they? How am I going to make a start on this one? Well, what do I know? Looking at the equation of the circle, x minus 5 squared plus y plus 3 squared equals 10. I know the centre of the circle. I know the coordinates of that point at the centre. That is going to be the point 5 minus 3. Okay. And so this gradient here is -3. This gradient is -3. I suppose I could draw this line here. Now, I think I'm getting somewhere now because I think I can find the equation of that green line. Because, you see, I know that it goes through the centre, and I know what its gradient is, because the gradient of the green line is perpendicular to the blue lines, so it'll be the negative reciprocal. So if I can find the equation of the green line, then is that going to help me find the equations of the blues? Well, it is, because if I know the equation of the green line, then I can find the points where the green line and the blue lines intercept, because they're the points where the green line and the circle intercepts. So let's start off by writing down the equation of that green line. So the equations can be y minus y1 equals mx minus x1. In this case, it's going to be y plus 3 equals 1/3 x minus 5, which is going to be y equals x over 3 minus 5 over 3 minus 3, which is going to give me y equals x over 3 minus 14/3. Okay, so there is the equation of the green line, and I'm going to solve that simultaneously with the equation of the circle to find the points of intersection, which for the time being I might as well call A and B. So let's find A and B by solving my equation 1 there with simultaneously with the equation of the circle. X minus 5 squared plus y plus 3 squared equals 10. And I'm going to substitute this expression for y in here. Okay, so that's going to give me x plus 5 squared plus x over 3 minus 14/3 plus 3 squared equals 10, which is going to give me x minus 5 all squared plus x over 3 plus 9/3, so it's minus 5/3 squared equals 10. So let's expand that bracket. X squared minus 10x plus 25 plus x squared over 9. What am I going to have here? I'm going to have it's going to be 5x over 9, isn't it? So it's going to be minus 10x over 9 plus 25 over 9, and that's going to equal 10. Okay, I'm going to multiply everything by 9. 9x is 90x plus 925 is 225 plus x squared minus 10x plus 25 equals 10. Let's simplify that. It gives me 10x squared minus 100x plus 200, and then take away a 10. Plus 250, take away 10 is plus 240 equals 0. Let's divide all through by 10. 24 equals 0. Will I be able to factorize this? Yes, I will. X minus 6, x minus 4 equals 0, which gives me x equals 6 or 4. So each of those, remember I'm finding the points A, B here, so I've got the x coordinates of A and B. So x is 6 or x equals 4. And remembering that y, looking at this equation here, y is x over 3 minus 14 thirds. So if x is 6, then y equals 2 minus 14 thirds, which is, well, 2 is the same as 6 thirds, isn't it? So it's going to be minus 8 over 3. And if x equals 4, then y equals 4 over 3 minus 14 over 3, which is minus 10 thirds. So I think I've got the coordinates of points A and B. One of them is the point 6 minus 8 thirds, and the other one is the point 4 minus 10 thirds. Okay, now we need to write down the equations of those two blue lines, don't we? Okay, I'm going to call them L1 and L2. Now, L1 and L2. For each line, I've got a point on the line. That's this one, or this one. And I've also got the gradient, which is minus 3. So one of my lines is going to be y minus plus 8 thirds equals the gradient times by x minus 6. Simplify this. Minus 3x plus 18. Let's subtract 8 thirds from both sides. Minus 3x, well, 18 is 50. 18 is 20. Is 54 thirds. Take away 8 thirds, leaves me with 46 thirds. So that's one of my equations, or one of my lines. And the other line is the line that's going to go through this second point of intersection. So it's going to be y minus y1, so y plus 10 over 3 equals the gradient, minus 3, multiplied by x, minus 4. So that's going to be y plus 10 thirds equals minus 3x plus 12, minus 10 thirds from both sides. So I'm going to get 12, which is 36 thirds, minus 10 thirds, which is going to be 26 thirds. So here are my two answers. The equations of the lines which are tangential to the circle and which have a gradient of minus 3. Okay, that is example 11.